Good morning, everybody. I hope everyone is staying dry on this lovely Tuesday. I just wanted to make a review video over some factoring methods that we have talked about in our polynomial unit, because that seemed to be a common thing that all of the classes had been struggling with during our review games. So I am making this lovely review video. Please like and subscribe to my YouTube channel. And let's get started. So the first method I'm going to talk about is factor by grouping. So factor by grouping is a special type of factoring where it only works if we have 4 terms. So here we have 4 terms. So the first thing that we should think about when we have 4 terms for a factoring problem is factor by grouping. And that is the instance where we're going to group our first 2 terms and then group the second 2 terms, and then we'll take the GCF out of both pieces. So I'm going to look at the GCF of just my first piece for now. Okay, I'm going to ignore the 5x minus 10. I don't care about that right now. So I'm going to look just at this guy. I'm going to look for a GCF. I notice that I have an x squared and an x cubed. That means I can take out an x squared from both of those. And I also notice that both of those numbers are also divisible by 3. So I'm going to take out a 3x squared. And I'm left with just a single x because I took away 2 of my 3 x's here. I took away both of my x's on my second term, so I have no x's left, and then 6 divided by 3 is 2. So I'm left with x minus 2, okay? Now, with factor by grouping, what I want to do, I want to make sure that this set of parentheses and whatever I turn this set of parentheses into are the same. If they aren't the same, then we have to try a different method, and we have to work a different method from there, okay? But if they are the same, I'm good to go. So let's see if we get the same. So I notice that both of those terms don't have an x, so I can't take an x out of both of those, but I notice that both of those are divisible by 5. So I'm going to take out a positive 5 in this case and see what I get. Okay, so 5x divided by 5 is x. 10 divided by 5 is 2, and I get x minus 2. Okay, so this is great. So I have x minus 2 in both of my sets of parentheses, which is great. That means factor by grouping has worked. So then I'm going to transform my 2 factors. Okay, I'm going to take pieces, my GCFs that I took out, my leftover pieces, if you will. That is going to form my first factor. So that comes from that. And then I'm going to turn my 2 sets of parentheses into my second factor. Okay, if you want to think about this another way, this is essentially just breaking down the distribution method. I am distributing 3x squared plus 5 onto x minus 2. I take my first term, distribute it onto all of the x minus 2, and I take my second term and I distribute it all onto x minus 2 as well. So that's all factor by grouping is. You group your first 2 terms, group your second 2 terms, take out your GCFs, make sure that those 2 sets of parentheses are the same, and those are your 2 factors. Okay, so that's factor by grouping. So now let's talk about one of the more recent methods that we've talked about, and probably the more difficult one because you have to be able to recognize it, is sum or difference of cubes. I'm just going to work out a difference of cubes, but the process is the same. So just to kind of remind you, if we have a cubed minus b cubed, the property or the formula that we would use is a minus b times a squared plus ab plus b squared. Okay, and I would figure out from my problem here in a second, I'll figure out what my a and b are. And if you were to have a sum, so if we had 2 perfect cubes with a plus in between, very, very similar. The only difference is 2 signs. This first sign with the a plus b, and then we have a squared minus ab, and that last one is always positive. Okay. So again, with the difficulty with sum and difference of cubes is being able to recognize that you have 2 perfect cubes and then subtraction or addition in between. So here we have 2 perfect cubes. So we have 27x cubed. What we do is we're going to take that cube root of 27x cubed. The cube root of 27 is 3. And the cube root of x cubed is just x. So this is my a piece of my equation. So wherever I see an a in my difference of cubes formula, I'll plug in a 3x. Okay, do the same kind of process with 8. Now, be careful. I just want you to use the 8. I don't care about the minus sign because the minus sign is taken into account with the formula. We have to just cube root 8. Don't cube root negative 8. You'll get something really weird. Okay, so the cube root of 8 is 2, so this is our b piece. So what I'm going to do, I'm just going to plug in wherever I see an a and a b, I'm going to plug in my respective values. So my first set of parentheses will be 3x minus my 2, because that is my a and my b respectively. Then I'll plug in to that 3x for that a squared, plus we'll have 3x times 2, and then we'll have our b squared, so plus our 2 squared. Oh, will I run out of space? No, yay. There we go. Okay, and then from there, you do have to simplify just a little bit. So my first set of parentheses will remain 3x minus 2 because I can't do anything to that. But on that second set of parentheses, I can simplify. Now, I want you to be careful. When we talked about this the first time, a lot of people only squared the x portion of this a squared part. When we are squaring a, if we have a number attached to our a portion, which we do in this case, you square all of a. So we're squaring the 3 and the x. So we'll have 9x squared. Okay, and then 3x times 2 is 6x, and then 2 squared is 4. So that is factor, or a factor via sum or difference of cubes. So again, the tough part about this one is being able to recognize when you have two perfect cubes. And then you have to make sure you plug into the correct formula. Okay, so if you have a minus sign, use the minus one. If you have a plus sign here, use that plus sign, but the process remains the same. The only thing that is different is those signs. Okay, let's move on to one that we're all pretty comfortable with, I hope. It is solving quadratics, and remember, quadratics are a very special type of polynomial, so we're still dealing with them. Okay, I noticed that I have 1, 2, 3 terms. Okay, so I can't do factor by grouping, but this is a term that we know and love. It is called the big X method. Now, you could use any method that we talked about before winter break about this. We could use the quadratic formula. I'm not going to sing the song, but we could use the quadratic formula. We could do completing the square. We can do big X, and I think those are the 3 methods that we mainly used before winter break. But I'm going to try big X first. If that doesn't work, I'll try the quadratic formula. So on top, again, will be a times c. So 2 times 20 is 40. And then on the bottom is b, so I have 13. So now I got to think about what multiplies to 40 and adds to 13. Okay, my 2 factors will be 8 and 5. But I want you to be careful, okay? Since a is not 1, meaning the number in front of the x squared is not 1, I must divide by that number. So in this case, I have a 2, so I'm going to divide both of my factors by 2, and then I'll simplify from there. So my first factor simplifies to x plus 4. Okay, my second factor, I can't simplify 5 over 2, so I'm going to leave it as 5 over 2. But I do not like fractions in my factors. I don't, they're ugly. Blech, no. Okay, so I have my x plus 4. Now, when we have a fraction in our factors, I want to get rid of that denominator. And the best way to do that is to multiply. And how that looks is I'm going to bring that 2 in front of that x. I'm multiplying everything in x plus 5 over 2 by 2. And if I multiply that fraction by 2, I get rid of my denominator. So I have 2x plus 5. So those are my 2 factors. And that's how we do the big X. I'm pretty sure everyone's pretty solid on this because we got a lot of practice with this over before winter break and after winter break when we started the polynomials unit. But that's just a quick review on that. Okay, the last method I want to talk about is called difference of squares. And difference of squares is very similar to sum and difference of cubes in that you have to be able to recognize it. It's not as easy to recognize as like big X or factor by grouping with the number of terms. You have to know that you have 2 perfect squares and subtraction in between. Okay. Now, with all factoring methods, you usually want to look for a GCF first, and I noticed that I do have a GCF here. I can't divide these numbers by a common number, but I noticed that both of my terms have X's. Okay, this last term has 2 of them, and this one has 4. So I can take out an x squared from both of those terms. So then I'm left with 64x squared minus 25. Okay, now my GCF is just going to kind of come along for the ride. He just kind of chills there. But I'm going to look inside those parentheses, and I notice the square root of 64 is 8. That's a perfect square. Square root of x squared is just x. That's a perfect square. Square root of 25 is also a perfect square because that square root is 5. Okay, and whenever we do a difference of squares, I'll write the formula over here. If we have a squared minus b squared, that is the same as a minus b times a plus b. Okay, so I'm just going to take the square root of both of my pieces and then plug in where I see there. Okay, so I have my x squared, my GCF just kind of chills there. The square root again of 64 is 8, so I will have 8x, and the square root of 25 is 5. Now one of them will be minus, and then the other one will be plus, and that is it. Difference of squares. The tough part about difference of squares is being able to recognize when you have two perfect squares, subtraction in between, okay? And then you just take the square roots, one is minus, one is plus, and you're done. You don't have to do anything else. We're done factoring, okay? So those were my four methods that I wanted to focus on for our polynomial unit. If you have any questions, please let me know. Again, please like and subscribe to my YouTube channel. That would be greatly appreciated. And I hope this helped. See y'all soon.